Well, good evening, everybody. Welcome. My name is Robin Goldsmith, and I'll be talking to you about proactive testing and risk-based test design. Tonight we're going to talk about proactive test design benefits. As you know, this is a free session, sometimes called a demo, and we'll try to have a bit of extra time at the end for your questions. So let me share with you the format that we're going to follow on each of these sessions. I'm going to start with a recap of the prior module. Some of you may have attended the orientation session. Excuse me. And what did I just do? There we go. So last time we talked about how testing takes typically half of a typical project, and yet a lot of the people involved with testing really don't understand much about it. Certainly project managers and users and developers. And unfortunately, oftentimes a lot of people who have roles in the QA and testing community don't understand a whole lot about managing it or carrying it out as well. And that's significant because developers make a lot of mistakes. And when I say developers, I'm including everybody involved in the development process. Analysts, project managers, coders, and so forth. And they tend to make many more mistakes than they're aware of. And the problem, of course, is that mistakes turn into problems. And they're the major cause of overruns and long projects and unhappy users. Testing is our main means of controlling and catching defects. And testing is there to confirm that things work, not to simply assume that they work. Developers tend to assume that things work because they wrote them. And I say that as a developer, a long-time developer. It's just the way we tend to think. And we find that it's hard for somebody to catch his or her own mistakes, that it's often easier for somebody else, an independent tester, to catch mistakes. And there are other advantages of having an independent tester because they are often better at testing, and they offer as well a second view. So if you have one person testing, you're not going to find as much as if you have two, as if you have three, and so forth. And so having an independent tester, somebody who is oriented toward testing, is going to improve the effectiveness and the efficiency of the testing and benefit the organization and the whole development process to really help the development process do what it's intending to do. Now, last time, those of you who attended know that we encountered some technical difficulties. And they were problems on my end. I apologize for that. But what I want to do is just repeat a couple of things that got interrupted so that we don't lose sight of these things. And we're not going to dwell on this, but I do just want to give a quick coverage to the topics that are going to be in the 12 sessions of this course. And as I mentioned, it's a good idea to think of these topics and all the information, much more information than any of you is likely to be able to use immediately. I want you to think of it like a cafeteria. Some of it you want to eat right away. Some of it you want to remember in case you have room after you've finished what you put on your tray. Some of it you want to think about for the longer term. In other words, maybe something that you didn't choose today, but maybe you want to get it tomorrow, and so forth. The other thing to remember is that every one of these concepts and techniques that we're discussing can be applied by you as an individual. It It can be applied at the team level. It can be applied at the department level. The more people that are using a technique, the more value you're going to get from it. The more people that you're trying to get to use a technique, the more difficult it is to get them involved. So do what you can do. Don't decline to do something because you can't do everything. Pick and choose, find things, make them work, and build on them. So last time we talked about the orientation, the value of testing. It helps catch problems before they become much more expensive and problematic. Tonight, we're going to be talking about proactive testing, a little bit about proactive testing, which is my methodology, which includes all of the concepts and techniques of traditional testing, which I would say is reactive, plus proactive testing has a number of additional advantages and approaches, and we'll talk about some of those benefits. As you develop your skills as a tester, both a traditional and, more importantly, as a proactive tester, you really increase your value to the organization, your ability to provide value. Okay. Now, tomorrow, we're also going to have another free session, and then we're going to be talking about testing and within what I call the proactive testing life cycle. So a life cycle is an orderly way of doing things, and so we're going to look at some of the key testing concepts, some of the differences among types and levels of testing, and how, when we do it proactively, we can more effectively address the various types of testing and development issues within the overall development life cycle. Testing is also risk-based. So our first paid session, which is next Monday, we're going to get into talking about risk, why it's necessary to prioritize tests based on risks, how you quantify risk, and how proactive testing identifies some risks, especially large risks, that traditional reactive testing often misses. Then we're going to be looking at some of the differences between proactive testing and reactive testing and how to go about planning and designing tests. And we're going to refer to IEEE Standard 829, which some of you may have heard of, and we'll show you some ways to use it in low overhead fashion. Then we're going to do what's called master test planning. And when we do master test planning from a proactive testing standpoint, we're identifying big risks, the types of risks that turn into showstoppers. Then we're going to look at how we identify test designs that are needed. A test design is a way to test a particular feature, function, or capability. And we're going to, at this point, distinguish black box testing and white box testing, the two major approaches. We're going to introduce to you a very powerful tool called the functionality matrix that helps identify test designs that you need. Then we're going to get into actually designing tests, developing a test design specification. And this is where we apply the many different specific test design techniques that every course on testing is going to discuss in one way or another. We're going to be discussing them, though, in more powerful ways. We're going to show you some more powerful ways to use them that help identify tests or test conditions that often are overlooked by more traditional reactive testing. Test design, the test design techniques is a big topic, so we're going to spread it over 2 sessions. And we're going to look at, in this section, we're going to look at some of the better known test design techniques. And once again, we're going to point out ways to use them more effectively and to avoid some of the pitfalls that, frankly, traditional testers often aren't aware exist. Then we're going to do something that's especially proactive that traditional testing really doesn't understand about, and that's how to make test designs reusable so that we can quickly know how to test something thoroughly. We can quickly choose those tests that are the highest risk, and we'll see how to have 2 different types of reusable test designs: atomic or simple reusable test designs, and then complex or business function reusable test designs. Then we'll see how to go from test design specifications to test cases, and we'll also point out how some aspects of test cases can be reused so that you can spend more of your time testing and less of your time creating tests. And then we'll tie it all together with a discussion about defining aspects of the test execution, the practicalities of that, and we'll talk about reporting and categorizing defects and evaluating the effectiveness of our testing. As you'll see at the end of this evening's session, at the end of every session, I'm going to give you an exercise to do on your own, and I think you'll find that you will learn more if you actually do the exercises. Now, because of the nature of the format of this class, I won't be able to directly interact with your answers, but I will present at the beginning of each class some typical answers that people give to these exercise questions. And I think you'll find that you'll learn a lot more. I want you to be aware that there are many books and other resources, websites and journals and magazines and conferences on testing. And I've listed some that are well known here. And these are by no means the only ones. In case you didn't notice, there is one book that's highlighted here. I do have a book. And you'll notice that the title of the slide is some testing resources, and yet the word testing does not appear in the title of my book. My book, 2/3 of my book, is about how you discover what the real business requirements are. And of course, requirements are pretty important both for development and for testing, because all of these books here that are listed above mine all deal with how you test that the delivered software conforms to or meets the defined requirements. My book, 1/3 of my book, deals with how you get confidence that the requirements are right, how you test or review that the requirements are right. So that's a type of testing that tends not to be addressed very well in the traditional testing literature. So it's not either or. Now, what you get out of this class is primarily dependent upon you, not me, not the materials. It's what you learn, not what I teach. And if you learn something but don't use it, it's the same as not learning it. So it's up to you to learn. It's up to you to use things. And I'm going to encourage you to approach things with an open mind. Don't try and squeeze everything into the current mold. Think about, how could I use this? How could I make it work in my situation? Now, Openness goes both directions, and I certainly will try to be as open as I can be as well, and address any of your questions as well as I can. I will assure you I will endeavor to answer them. I cannot assure you I'll always give you the answer that you want. Now, part of your responsibility for your results is making sure that if you have issues, you let me know about them while I have time to address them. That's how you get what you need. That's how I get what I need, so we can both improve. Now, at the end of the final session, you're going to be asked to complete some kind of an evaluation. Okay? You're perfectly entitled at that point to say the course was no good, but I will encourage you to realize that if you have not done anything to make it better, then that's not a fair evaluation. So hopefully everybody will take personal responsibility for your results. That's how you get the results. This is a diagram of the courses and consulting that I do and their relation to the various phases of the development life cycle. All of these are available through ITE Learn. And other than a blatant ad for my courses and consulting, the real reason I'm showing you this is to highlight where testing and the topic of this course tends to fit within the overall development life cycle. Okay. Now, for the most part, testing gets carried out at the end of development, after programs have been coded. We're going to see that we get far more effective when we move to the left, when we do more as part of design, when we plan and design our tests before the code is written as much as possible. So that was a brief recap of some of the things from the orientation session. And now let's look at what we're going to discuss tonight, new topics. First of all, we're going to talk about processes. And there's two types of processes, the real process and presumed processes, and we'll make a distinction there, and I think you'll find that it's an important distinction. We're going to talk about typical testing experiences and relate that to processes and your own experiences. We're going to look at where errors occur within the development process and the economics of finding and detecting and fixing errors. Because testing is our main method of catching errors. And the earlier we can catch them, the easier and cheaper they tend to be to deal with. And then we're going to make some distinctions between traditional reactive testing and what I call proactive testing. And I think you will find that proactive testing offers you the opportunity to use traditional testing techniques in much more effective and more powerful ways, so that you'll be providing a lot more value and you will be more valuable. And then, as I mentioned, at the end of each session, I'll give you an exercise that hopefully you will do on your own, and then at the beginning of tomorrow's session, we'll talk about the exercise and some typical answers that students in previous classes have given. So let's talk first of all about what is a process. I'm sure that many of you use this term, and think about what you mean by a process. And if you're like many people, you tend to define a process as a set of steps or actions that should be taken to achieve a desired result. Now that's a very common definition. It's also one of the reasons that people have so much difficulty improving their processes, because a process is not just steps and actions. It's also beliefs and customs and practices and skills and knowledge that, taken together, produce a result. So if you have a result, it is the outcome of the process that you followed. Regardless of whether you were aware of that process, regardless of whether that process was intended, regardless of whether that process was even desirable. That is, when people get bad results, it's because of the process that they followed. Now, the reason that this is important is because if you know what your process is, then you can predict and, in fact, create your results. So if you repeat the process, you will get basically the same results. I'm sure many of you are familiar with the definition of insanity, doing the same thing over and over and expecting different results. Well, that's because if you do the same thing over and over, you're going to get the same results. It's insane to expect different results. There are two types of processes. There is the real process that's producing your results. And very often, people are unaware of the real process. And then there is the presumed process, what people think is producing their results. The presumed process is often a defined process. Now, a process can be defined without being documented. If it is documented, indeed it is defined. But for instance, if I hold the door open for you, you say, thank you. That is a defined process. We all know to say thank you if somebody holds the door open for us. But it's not a documented process. There's not a sign up next to every door that says say thank you if somebody holds the door open for you. So if we want to change our results, what do we need to change? We need to change the process. Well, which process do you think people change? The real process that's actually producing the results that they may not even be aware of, or the presumed process that they think is producing the results? Well, of course, they're going to change the presumed process. If, as so often happens, the presumed process is different from the real process, then the presumed process is not actually producing those results. Changing a presumed process that is not producing our results currently is unlikely to produce the desired change. So if you want to make meaningful change, which process do you have to change? You've got to change the real process. And to change the real process, first you have to recognize what it is. We refer to the current real process, the one that's actually producing our current results, as the as-is process or current state. And we refer to the process that we want that will presumably produce our desired results as the should-be or future state process. The should-be process is the requirements. Now, processes get tricky because of what are called silos. So if you're familiar with farms, you know that farms often contain silos, tall, cylindrical structures that they keep food for animals in. If you were inside of a silo, your view of the world would be very narrow and very out of context, and you wouldn't have any way to know what was going on outside the silo or in the silo next to you. Because of that, when people act as if they're in a silo, which happens in organizations, they tend to view things out of context, and they get an inaccurate picture of what's going on. In other words, that's a form of a presumed process that often is different from the real process. So when we work with processes, and we all do, we need to look at the process from the beginning to the full end result. So let's see how this works. So I'm sure that many of you are familiar with projects where some coding has been scheduled and some testing has been scheduled, and they are supposed to be done by the stop sign, the deadline. And I'm sure many of you have also seen projects where the coding takes longer than expected. Now, if the amount of testing is somehow proportional to the amount of coding, and you have more coding than expected, then you should also have more testing than expected. But what doesn't change? The stop sign, the deadline, right? And so what happens? The testing gets squeezed, and we reliably deliver trouble. Now, have any of you ever seen this happen? I bet you have. As a matter of fact, I think many of you would say it happens, you've seen it happen many times, in fact, practically every project. Well, if that's what happens practically every project, then that is your real process. And the thing at the top is the presumed process, and it's a myth that doesn't really occur. Now, I challenge any of you to go to anybody in your organization and ask them to describe your software development and testing process, and have any of them say, we plan the coding and testing to be done by the deadline, we blow the coding, we take longer for that, we squeeze the testing, and we deliver trouble. Some of you are probably laughing. People often laugh at that. Why are you laughing? It's true. It's not funny. That's the problem. Okay? Our real process is that our organizations are very well able to repeatedly produce trouble. And it's because of the way we do things. Now, when people focus just on a deadline, you got to realize anyone can deliver by a deadline if it doesn't matter what they deliver. And so what we've got in the traditional development and testing world is a silo from the beginning of the project to this artificial time called a deadline. When you look at organizations that truly deliver excellence, okay, they know that the process is not done until things work right. And that means until the problems have been fixed. Organizations that deliver excellence realize that the results that they get are due to the process that they followed. If they're not getting the results that they need, it's because of the way that they did things, and they go back and fix the process. In the information systems world, that very seldom happens. In the information systems world, we tend to act as if development is unrelated to its results. And because of that, we keep repeating this undesirable real process. Now let's look from a different standpoint at what happens when we develop systems. We start by defining requirements. Some of those are required and defined appropriately, and some of them are in error. Things could be extra, they could be left out, they could be misdefined. When we go from requirements to design, that's a translation process. Some of those appropriate requirements are translated into an appropriate design, and some of them are lost in translation. I'm sure that many of you are familiar with the concept of losing meaning when you translate from one language to another. We also lose meaning when we translate from one phase or artifact to another. Similarly, when we go from design into building and testing, some of the appropriate design is built and tested appropriately, and some of it is lost in translation, all the way down through implementation. Now notice what happens. Once something is wrong, it tends to stay wrong. And at every point in the process, we're losing more and more correctness. So the real process, the real development process, is one of continually diminishing quality. That's not the way people think of it. And the fact is, we don't deliver worse stuff than we start with. Now, one of the ways that we correct this is through testing. Testing is primarily demonstrating that the design has been implemented in the product as designed. And there's a trap here, because developers are perfectly capable of implementing incorrect designs. And testers are perfectly capable of confirming that that incorrect design was implemented as designed, with neither the developer nor the tester having a clue that the design was wrong. By the way, the major source of wrong designs is wrong requirements. When we get proactive, we have opportunities to dramatically shift this dynamic, to considerably improve upon the effectiveness of the whole development process, to catch and prevent errors before they persist down through implementation. And when we look at how this plays out from a dollar and cents standpoint, maintenance, changes to systems after they go into production, is where we spend the bulk of our system costs. And contrary to popular opinion, much of maintenance is not new and unpredictable, but rather much of maintenance is finishing and fixing what we could have and should have known in the first place, largely due to wrong and missed requirements. Things that various forms of proactive testing can help catch. When we look at finished systems, about 2/3 of the errors in finished systems have been there from the beginning. They are errors that were wrong in the design and usually also in the requirements. 2/3 of the errors are ones that traditional development and traditional reactive testing are unlikely to be able to address. Proactive testing can help with a lot of these errors that are ordinarily overlooked. Now let's look at the financial significance of this. If there's a requirement error and it's not caught until after it's been coded, it's easily going to cost 10 or more times as much to fix than if it had been caught before it was led to incorrect coding. If that requirements error doesn't get caught until production, it's orders of magnitude more expensive to fix, 75, 100, 1,000, or more times as expensive to fix. So the time to catch problems is as early as possible. The earlier you catch a problem, the easier and cheaper it is to fix. Okay? Proactive testing helps catch more problems earlier when they're easier and cheaper to fix. Now, I'm sure that you've heard these types of statistics before. I'm sure you can understand why it's so much more expensive the longer it takes to find a problem. The question is, does your organization have routine measures that show these effects so that people can see what's happening? They can see the extent of it and can see the impact of it. There's a pretty good chance that they do not. When people cannot see what's happening, then they act as if it's not happening, and that increases the risks that these problems will occur. Proactive testing helps you make things more visible. In the orientation, we used this slide to point out that when the developer's understanding of requirements and the tester's understanding of requirements match, that gives us a basis for corroboration and confidence. Now let's look at it from a different standpoint. When there are no requirements, the developers have to guess, the testers have to guess, and the chances that both are wrong become much higher. And as so often happens in traditional development and traditional reactive testing, the testers don't have good information about the requirements. And when the testers don't have awareness of the requirements, then they're unlikely to test accurately, and they're very subject to being ignored. Proactive testing helps cut down on all of these shortcomings. So let's look at this portrayal in a little bit different way. Traditional testing is reactive. It tends to come at the end of development. It tends to react to what's been coded. Not surprisingly, traditional development projects are driven by the development side of the house. And developers tend to think that coding is more important than testing. So that if time gets short, the things that get sacrificed are the things that are considered less important. In other words, testing. If you're familiar with project management, perhaps you know about work breakdown structures. The concept of a work breakdown structure is to identify in detail the various tasks that need to be done, the various work that needs to be done. If you identify that this, that, and this other thing all need to be done, well, that's going to create a commitment to do those things. However, when you don't have that detail, there tends not to be commitment. And with testing, there tends not to be detail. And so what happens is that we get vague estimates and no commitment. Very often, testing is estimated by some kind of a rule of thumb. So if we have 3 modules and each of them is planned for taking a month to code, we might say, well, if it's going to take a month to code, then it should take a month to test. So Module 1, Module 2, Module 3, each of them should take a month to code and a month to test, a total of 6 months. That's a rule of thumb. The problem is there's no commitment to that rule of thumb, because if Module 1 takes 6 weeks to test or to code, it's not going to be given 6 weeks to test. Instead of saying we have a month of testing for a month of coding, suddenly that rule of thumb slips. Oh, we'll have a week of testing for a month of coding, or a day of testing for a month of coding. So rules of thumb tend to slip. And then it's very common that the testing is all lumped into a single lump or task. So we've got 3 one-month coding tasks, and then we say, oh, and then we're going to have some testing, and who knows how long is going to be given to that, but it's probably not going to be nearly enough. And frankly, what often happens is the testing is allocated the time that's left after the important stuff, after the coding is done. It's very common that testing is done as if you're wearing blinders. Blinders are things that horses in horse races wear to block their vision of horses next to them so they don't get distracted. If you're wearing blinders, you tend to just react to whatever is in front of you. And whatever is in front of you may or may not be the most important things to test. In addition, the tests that get squeezed tend to be the later tests, and the later tests are usually the more important tests, the ones that are dealing with functionality fitting together. Some of what is not tested are things that we know about, but we just don't have time to test them. some of what's not tested are things that we don't even know about. Showstoppers, big bad problems, are primarily due to things that we don't know about, because if we knew about them, we would test them. Now, when we get proactive, we do things differently. We start anticipating, and we're going to let testing drive development. Now, this is not a political distinction. This is a knowledge distinction. We're going to let testing information help the developers do their job quicker, easier, and better. We're going to make testing as important as development. We're going to plan our testing in the same type of detail as the development so that we have the commitment and clear estimates. Okay. We're going to get rid of that rule of thumb stuff. We're going to take off the blinders so we can be more selective. And we're going to move more of the more important tests earlier in the process so that if we do run out of time, we've done the more important ones. We want to test more of what we know and know more to test so that we get fewer showstoppers. Now, I think you can see that that describes a considerably more successful, more desirable outcome. Proactive testing represents a big change. In fact, it's called a paradigm shift, a different way of thinking. Now, the problem, of course, is that people tend to resist change. The fact is, people don't resist all change. They primarily resist change that they fear will hurt them. And if they don't know why something would not hurt them, they fear that it will. They don't resist things that benefit them. So when we get proactive, we identify and deliver what are called WIFMs. What's in it for me? Things that developers, managers, users find save them their time, their effort, their aggravation. And when people see that, they greet the testing in a much different, more constructive way. So, hopefully this has been understandable. If you have questions, chat them to me. Let me tell you about the exercise that I'd like you to do between now and tomorrow. I think you'll get more out of the course if you do it. And that is that even if it's not documented, most organizations have some kind of a defined way that they go about testing. And what I'd like you to do is jot down what that defined way of testing is, what your defined testing process is. I think you'll find, among other things, that simply the act of thinking about it and writing it down will be instructive for you. So, hopefully this is understandable. Tomorrow we'll start up with reviewing the exercise. And so does anybody have any questions? Is there anything that you'd like to find out more about the course? Are we going to get notes from you? Okay. And Alex, thank you. So let me try to answer these questions. First of all, the materials. If you look on the IT eLearn site, you will find that there is a place where you will be able to access the recorded version of each class. The ones that if you're just taking the free classes, you'll be able to access the orientation session and tonight's and tomorrow night's free classes. If you then sign up for the paid portion, you'll be able to access all 12 sessions, recordings of all 12 sessions. In addition, it's my understanding, and I don't know the mechanics of this, but it's my understanding that you will be able to get access to copies of the slides, a PDF of the slides. So that's hopefully that's understandable and helpful. And so let me see if I can find. Now we've got a couple of questions that are similar. Okay. And so these relate to how do you convince other people to do these things. Now, the first thing that I'm going to tell you is that you are going to be more convincing if you learn and use the techniques. Don't just tell people about them. If you just tell people that there are these good techniques, go try them out, it's very unlikely that they will do anything. So when you go through all 12 sessions, and we'll have exercises, and you'll see examples and so forth, you'll have an opportunity to develop a far greater understanding. And then, as we suggested, pick things that you can make happen in the short term. Make them happen. Use some techniques. Use limited things. Don't overload your plate. Pick one or two things that you can make happen. Make them happen. Make them succeed. If they don't succeed, don't abandon them. Figure out what your problem was and go back and correct it and make them succeed. As you succeed with one thing, that gives you two benefits. One is you're more successful. The other is that it tends to improve your time. You have more time because you're not bogged down with things that used to bog you down. And that means that you'll now have time to try the next thing and so forth. As you increase your effectiveness, other people start noticing. Now, you can tell people what you're doing, but it's much more convincing when you're also showing them that you're doing things more effectively. Now, throughout the course, we'll also talk about particular techniques and how they can help you influence and bring along other people. It's kind of hard to talk about that without more specifics on the course. So hopefully that's helpful to you. Now, there's a question about Agile. Agile, and I'm sure many of you use Agile, and of course Agile is a term that pertains to many different techniques. So if you're using extreme programming incorporates several testing concepts as part of the Agile development process. Pair programming, test-first development, and user story acceptance tests. What Agile, and those are all things that are consistent with proactive testing. I give a speech, a presentation called Proactive Testing Puts Agile Test-First Development on Steroids. Because what Agile doesn't do is know how to test well. They're encouraging testing, but it's not really the focus and the skill set of most of the people. And so when you learn the proactive testing techniques to plan and design the tests, you can make the Agile far more effective. You can make the tests that they do far more thorough, far more effective. So Agile is not our focus in this class, but it certainly is something that can benefit from proactive testing. And proactive testing is an iterative process. It doesn't rely upon any particular development methodology. So tools, this is another important thing. When you say tool, you're talking, I presume, about automated tools. What tools do we use for this testing? And proactive testing is not assuming or relying upon or dependent upon the presence of any particular automated tool. An automated tool is only as effective as your testing process. Your testing process is the means by which you ascertain what tests you need to run. A tool will not tell you what tests you need to run. Many people have tools but don't have a good definition of tests, and the tools, frankly, don't help them that much. Proactive testing gives you the basis for identifying the most important tests and then selecting from them the ones that are most appropriate to be automated with some kind of a tool. And there are a variety of tools, types of tools that could be helpful. What's the basic requirement for a QA tester who doesn't have any software background? Excellent question. This is one of the continuing points of discussion within the development and testing community. Historically, testers are often people who do not have a programming background, because for a large part of what a tester is doing, you're there representing the users and the business. You're there to confirm that what the developers did works from the standpoint of the business and the users. You need to be in the shoes of the users in some ways. So that does not by itself require technical knowledge. Now, I'm not going to say that technical knowledge is not helpful. The more knowledge that you have, the more capabilities you can bring to the situation. But I will point out that developers have technical knowledge, but often are very poor at detecting their own defects. So you as a tester have to be able to look past the developer's mindset to be able to identify the things that the developer didn't identify. So technical or coding knowledge is not essential. If you've got it, good. It's an added skill set. And if you're involved with automating tests, technical knowledge becomes more helpful. Where do we use this testing? As it is software testing, how does this support IEEE standards? Okay, so there are a couple of questions within this question. Where do you use this testing? You use this testing throughout the development process. Proactive testing includes ways to catch problems in requirements and design. Some of those we will be covering in the coming classes. There are many additional techniques that are beyond what we can cover in just these 12 classes, but we'll probably cover them in a future class. But among other things, by planning and designing tests, you help reveal requirements and design errors. If you can reveal a requirements or design error before it turns into production error, you've saved a lot of time, effort, and aggravation, and embarrassment sometimes. So testing occurs in conjunction with development. Traditional testing often does not occur until after the code has been written. When we get proactive, we try to get involved earlier, planning and designing our tests as much as possible before the code is written, and that helps the developer code more correctly. Now, the other question is, how does this support IEEE standards? And in fact, we will identify and talk about several IEEE standards, most notably IEEE Standard 829, which is the best known standard dealing with test planning and design. I will tell you that I was a member of the working group that developed the current revision of IEEE Standard 829. I'm pretty familiar with it. I will tell you that many people, in my perception, misunderstand and misapply this standard. When we get proactive, we apply it in a high-value, low-overhead manner. That's often not what's done. We use it as a way to help us organize our thinking, and our thinking is our highest payback activity. How do you create test cases when there is no requirements document available? Fantastic. That's a much bigger question than we're going to be able to get to tonight. Okay? But the fact is that that's a significant benefit of proactive testing, because when we get proactive, we use methods that help reveal requirements that are ordinarily overlooked. So that's the short answer, and as we go forward throughout the remaining sessions, you'll see more and more instances of methods that help. Ultimately, you do need some requirements, but I recognize that oftentimes they're not there. Okay. If I take this course, do you think I can write a better test plan and test cases? Absolutely. That's what this class is about. This class is about giving you insights into and approaches to and techniques for developing test plans and test cases. A test plan, by the way, is a project plan for your testing. Test cases are the executable inputs and or conditions and expected results that you actually execute. Let's see. Why is experience in one field more effective on the market than knowledge in many fields? Well, I think that what you're saying is there a value to depth as opposed to breadth? And the answer is that very often depth is something that is going to be more immediately useful to people. Breadth is important, but more commonly breadth is more important for people who are dealing at higher levels. And if you're trying to get a job in a development project and you're coming in as a tester, your ability to get that job and your ability to perform that job is going to be enhanced by depth of knowledge and experience at testing. By the way, how do you get experience? Doesn't occur instantly. You can't start with 10 years of experience. Everybody's got to start somewhere. You're going to have an advantage if you have an understanding of the concepts and techniques and how to go about things. If you don't understand those things, if you only have a screwdriver or a hammer, you're probably not going to be able to be very effective. So I think you'll find that that the concepts and techniques that we're teaching is something that will help you. It's not going to get the job for you. It's something that will help you be able to get a job. It's something that will help you perform on the job. But ultimately, you're the one who has to use the methods and make them work and learn from the course and learn from your experience. Alex says it would be great if this training can be made interactive. I agree with you, Alex. The particular practicalities of the training mechanism limit our ability to be overly interactive. So we have kind of this compromise approach, and that's why I give you the exercise at the end of each class. Try and give you a chance to work on that and then share. Let's see. Do you know any IT organizations which have evaluation systems with emulations of processes, tools, methods, etc.? I'm really not clear, Igor, on what it is you're asking about there. You know, there are many organizations that have individuals and groups who are charged with evaluating how things are done within the organization. Quality assurance in its classic sense is involved with evaluating how processes are used. Testing is evaluating whether development is developing what they're supposed to be developing. So I'm not sure whether that's pertinent. You know, you have groups like auditors that are involved with evaluating various types of processes and systems. Okay. So we have a question about QuickTest Pro, which is a very popular automated test execution tool from Hewlett-Packard, formerly from Mercury Interactive, and it says QTP needs VB scripting. What kind of scripting is required in this testing? This testing, what we are teaching you is how to identify what tests you're going to run. What are the set of tests that are going to provide you the greatest benefit, the greatest value? From those tests, then you can make decisions about which of those are good candidates for automation. Some tests are not good candidates for automation. In fact, they're a waste of time to automate. So this class is not about using any automated test execution tool. This class is about identifying the tests that would make an automated test execution tool useful for you. So you don't need to know any scripting. Okay. Are we going to experience a live project in the course? We're going to be using a case study as a basis for planning and designing tests and developing test design specifications and test cases. So there will be a fact situation. And as I said, at the end of each session, I'll give you an exercise that I'd encourage you to do yourself, and then at the start of the subsequent session, we'll go over typical answers. What are testing tools to use during the course? Once again, as we said, this course is not a class on the use of testing tools. This class is on how you identify the tests that a tool might be helpful for. If you do not understand how to identify the appropriate set of tests to automate, your automation efforts not only will not pay off, they will backfire. They will be a waste of time. Okay. Now, unfortunately, too many people concentrate on the tools and not enough on the tests. Okay. So, like you check Excel knowledge, for example, yes, QA process in a real app. I'm not sure what that means, Igor. You know, once again, Excel is a tool that some people use to help them capture testing information. You know, we're not assuming that you use it. Okay, what is the cost of the whole class? Okay, so I think that the cost of the class is $350 if you just want access to the recorded, or videos they're referred to as, to the recorded versions of the class. If you would like to attend the live sessions like this, where you have a chance to ask questions, as you're doing now, and to some extent a chance to influence the subsequent classes with your questions, for instance, that costs an extra $50. So it would be a total of $400. Now I've got to tell you, I deal with many people in the training world, and I will tell you that these classes are a bargain. This class, when it's presented, when I present it live for typically in a 2-day live in-person session, the cost for that class would ordinarily be 2 or 3 or 4 times as much as the fee for this class. This other advantage of doing it in the evening and in 1-hour segments, is another thing that I think is a very attractive format. And the $400 includes the access to the videos, the recorded versions of all 12 sessions. And it's my understanding that it also includes access to the PDFs of the slides. Let's see. Looks like I missed something here. Hold on. So, do I accept any email queries from attendees? Indeed, I do. Okay. My email address was it's on the first slide, and it's robin@gopromanagement.com, and I certainly would be delighted if you've got queries, and I will generally I would be addressing them in the class, not necessarily directly by email, because that could become overwhelming. What types of testing a tester should perform for the project? Excellent question. Okay. There are many different types of testing. Some of those types of testing are distinctions between what are called static and dynamic testing. Dynamic testing is executing tests, executing the code. Static testing are things like reviews and inspections. This class is dealing only with planning and designing and then managing the execution of dynamic tests. Dynamic tests include unit tests, integration tests, system tests, user acceptance tests, regression testing, which is repeating the testing that you've done previously. There are also what I call special tests, things like performance testing, load testing. And then there are the variations based upon how you carry them out, whether they're manual or automated and so forth. So we're going to be dealing with many of those types of tests. We're not going to be dealing with automation per se, but the planning and designing of tests is pertinent to all types of testing. Okay. Good. So I think that I have addressed everybody's questions. Let me go back and see if there's anything else, and if you still have any questions that I haven't answered, give you one last moment to chat them. Okay. So, So indeed, I think that you will become familiar with approaches and techniques, strategies and methods that you can use to make you a more effective tester. Okay? And that you can apply that in Agile and other types of development, and that you don't need to know coding, but it certainly would not hurt you. Okay? So I hope that you found this helpful. Hope that it's been understandable. Okay. We've got the another free session tomorrow, and then hopefully you will decide that you want to continue on for the remaining sessions. So let's see, got one or two more notes. Good night, Mohammed. Good night, Igor. Good night, Kartika. Okay. Thank you, everybody. Hope to see you tomorrow, and then in the live sessions starting on Monday. So thank you much. Good luck.